Welcome to this next video, guys. Today we're going to be looking at the idea of introducing and then going to talk about simplifying this idea of ratios. Okay, right, our learning goal, we're going to be hoping that students, you guys will be able to solve everyday problems involving rates, ratios and percentages, and at the end of this and after your exercises you should be able to communicate the situation in terms of ratios and represent a ratio in its simplest form. All right, now ratios everywhere, wherever you look. Probably one of the easiest examples to think about is the idea of baking. And so, for instance, you might have 2 eggs per 5 cups of flour per 7 bags of sugar. Okay, if you want to like the grossest cookies you've ever tasted, maybe. Also, another one for you to think about is that idea that if you're making 2-stroke fuel, so you need to mix the fuel in a particular ratio of petrol to oil, and that should be 50:1. And so that means for every 50 parts of the petrol that goes in there, you need to have 1 part of the oil. Okay, now if that's sort of a bit new to you, it's something you'll sort of get to see, have a play around with as we go along. Okay, so the colon symbol, some of our key ideas. Colon symbol, this one here, is used in mathematics for this particular area to denote a ratio relationship. Okay, so if we have 7:5, this way you'll kind of want to read this is that some ratio is 7:5. Okay, so that's the way you want to read that. So that means 7:5. So hey, what's the ratio of apples to oranges in that basket you've got there? The ratio is 7:5. Okay, that's the kind of way you want to read it. That's sort of the way that it's going to get communicated. Okay. Now, the order that ratios are written is very important, and they all need to be in the same units. So especially before, when we're talking about that mixing the 2-stroke fuel, if you have 50:1, that doesn't mean 50 liters is to 1 milliliter of oil. Otherwise, you'll get that totally out of whack. When you're communicating a ratio, you should be you have to communicate it in the same units. Okay, otherwise it doesn't make any sense because they're supposed to be unitless technically. Okay, right, so the order that ratios, so we have a box of chocolates. Pretend that has 7 plain, 5 nut and 3 soft scented chocolates. What is the ratio of nut chocolates to plain chocolates? So you might write, okay, I want nut is to plain. When I look at this, okay, nut is 5, so I'm going to have 5 is to 7. So it's important because we wanted the ratio of nut chocolates to plain. So that's why we have to have 5:7. You can't just write, oh yeah, 7:5, 5:7. No, you've got to give it in the right order so that it all kind of makes sense. Okay, next one. Now, similar to fractions, you can create equivalent ratios by multiplying or dividing all the different parts by the same amount. So if we have this 5:3 here, we can go 5:3, and I'm going to multiply this side by 7, this side by 7, and if I've got 5 times 7, that's 35, is to 3 times 7, 21. Okay, so that's a simple thing for us to be able to do, same as with fractions, to be able to create equivalent fractions by multiplying numerator and denominator. With ratios, as long as you're multiplying all the different parts of it, it's no problem. It's also no issue if you've got more than 2 pieces in the ratio. So you might have 2:3:5. No problem there. We're just going to times by 2 for everything. So you'll have 4:6:10. That would be the same set of ratios. No problem at all. Okay. Next one here. So to simplify ratios, you need to divide all parts by their highest common factor. Okay. So if we have 12:34 here, well, highest common factor of 12 and 34 is 2. So that means we're going to divide both sides of that by 2. So if I get 12 is to 34, divide by 2, divide by 2, we're going to end up with 12 divided by 2 is 6, 34 divided by 2 is 17. So that's the simplest form of that one. Okay, same as with fractions. You've got to do the same thing with ratios. You want to communicate everything in its simplest form. Alright, so same if there is 3 of them. So with the 3 here, 3, 12, and 16, our highest common factor of 3, 12, and 6 is 3. Okay, so again, like just having a good handle on factors and that kind of stuff is really going to help with this sort of stuff. Okay, so that means 3 is to 12 is to 6. Everything's going to get divided by 3. And we're going to end up with 1 is to 4 is to 2. Okay, and again, that is exactly the same ratio as the one we had before. Okay, now ideally ratios should be given in whole numbers, okay, because it's sort of just the easier way for you to sort of work things out. Okay, and so you should be multiplying our fraction ratios by their lowest common denominator. Okay, so again, this is sort of coming out. There's ideas of fractions, you're never going to get away with it, and here's another good opportunity maybe for you to get a handle on it again. Alright, so if we have this one here, 4/5 is to 2/3. Okay, now this might not make a lot of sense multiplied by their lowest common denominator at the very start, but we're going to kind of show you how that's going to work out. Now, our lowest common multiple of 5 and 3 is 15. Okay, so that means that we're going to create some equivalent fractions here, so we get our fractions on the same denominator. Alright, so we're going to have times by 3, times by 3, times by 5, times by 5. And so our new ratio will be 12 over 15 is to 10 over 15. Right, once we're at this stage here now, remember we're allowed to multiply everything by the same amount, and everything's going to be okay because we still have an equivalent ratio. Now, as you can see, I've just multiplied both sides by 1 because 3 over 3 and 5 over 5 are both 1. Okay, now that I've got 12 over 15 and 10 over 15, I'm going to multiply both sides by 15. Okay, and we will get, so I'll sort of write the full kind of version of this so you can sort of see what's going on. 15 times 12 over 15 is to 15 times 10 over 15, and I'm sure you can see that this one cancels, and we're left with 12 is to 10. Okay, this line here, probably okay with you skipping that as you're working this out. Okay, because it could get a little bit messy sort of writing that line, and really that I just wanted to show you kind of the maths, nuts and bolts of what's happening behind the scenes there. Okay, look, I hope that was a good introduction to ratios for you, and you'll have plenty of time to practice that in class, and please come and see me if you have any issues. Okay, thank you.